With your mentor Abhilash Sarkar. Now we are discussing on the theory part of ratio and proportion. There we have shown few many keys, and after that we have described some of the corollaries. Now few are the more improvisation you can say regarding this ratio, because there are so many things can be described as a corollary, because those are in the process of proving the formulas, or that itself can be taken as a direct method of doing problem solving. So those, instead of taking as a so many of corollary and remembering those, you can do your own and can bring those relation. But the most important improvisations that I will describe right now, it is a universal method of converting any ratios into their respective relation with the term, with the extremes and the means. So let me describe, then you will be able to understand it is better. So now, as I said, if I am talking about let's say four quantities, where A, B, C, D are the quantities, and they are related in such a way that A by B is equal to C by D. Now, as I said, this is the ratio, and these ratios of the respective A by B quantities and C by D quantities are same. So we can take, as I already said earlier, this a constant, because whatever value, let's say 2 by 3 of a taking, that can be converted into some decimals, okay, isn't it? 0.66, and if I do the similar, if C by D something, that also can be converted into some decimals. So let it be K something. I am not very much interested in the specific values of that decimal. Rather, if I can describe it as some constant K, that would be the same for these ratios. Okay. So now, what is the improvisation? Improvisation that if I take this with K, so as I said, that can be represented dk. Let it be your first equation. Now, if we do this for this case, equal to dk. Okay, this is your second equation. Okay. Now, if something, and this, if it is, then that can be said that A, B, C, D. If I want to get the continued ratios for that, the continued ratios where B and C will do LCM, and I can convert it as, for this, AC is to BC is to BC and BD are in continuous, because A by B, what I will do, I will multiply it with C, and to make it same, I will multiply it with let's say B. So now AC, BC and BD are in continuous relation, continuous ratios. So in this case, A can be represented BK and C can be represented DK. Okay, so now if I multiply it with C, and here I multiply it with B, now this, and again if I multiply it with K square, because whatever I am multiplying with the both side of the equation. Now this will not change the value. Now here see, CA, that is equal to BCK, and that is equal to BDK square. So I can convert all these relations into one term, in one relation. Instead of two, I can make it equalize. So what is the advantage of this? Now let's say I am having some numbers A, B, C, D are in continue proportionally. Continual or continued proportion. If it is so, then what would I can say, that A by B is equal to B by C is equal to C by D. Can I write it? How can I write it? Because if I am assuming these are in continuous relation, what is the thing that I have to look after? Any number, as in case A, B, C, D, has to be in continued proportion. Then this we are doing the LCM. Now in this case, for first three terms A, B, C, if it is in continued proportion, then we have to do these two terms LCM. So now these two terms are equal. So if these two terms are equal, your LCM will be always the same, B. B will come as an LCM. So instead of taking A, B, C, D, if these two terms are same, then we can write it, instead of doing AB, BC is equal to BC, BD. So we can, instead of this term we are making equal, instead of that, if it is equal itself, so I can put A by B, B by C, and these are equal. All means if we keep same, so then the terms always to be in continued proportion. Now if it is the case, now if you find this is the case where all numbers are in continued proportion, if it is said like that, so then we can take these are the these are having some constant k. Let me assume it is k. Earlier case also I have taken a k, this time also k, but this is particular for individual problem. This k and earlier k may not be same, but for a sum I can take it as a k. Okay, now what else? A can be written as bk. If I equalize this to this, if I equalize this to this, b is equal to ck. So now b is equal to, we can put it here, ck square. Now c is equal to dk. Now what else? C can be come here, and c and b, ultimately it is c is equal to dk. Okay, so now c, if I can put here, sorry, what I did, a is equal to bk, instead of b I am putting c, so ck square, b is equal to ck, from this relation is equal to ck, and c is equal to dk. Now b, if I put here, it is ck square. Now c is equal to dk square, isn't it? So ultimately, if I put b in terms of d, so dk cube, c is equal to dk square, b is equal to dk square, and c is equal to dk, and d itself is, so if I say a is to b is to c is to d, as they are in continued proportion, we can write as continued proportion a, b, c, d. Okay, in this form, and this will become a is equal to dk square, dk cube, sorry, b is equal to dk square, c is equal to dk, and d is equal to d itself. So everywhere d is multiplied, so d is not giving any contribution to the relation, so this will become something like that. So if in case some number a, b, c, d are in continued proportion, their relations are become a constant. So that depends on highest power of k. If it is 4 term, so that will become the number of term minus 1 is to number of term minus 2, number of term minus 3, and is to number of term minus 4, and likewise how many number is there, it will go till the number become 1, k to the power number become 1. So this will become term minus term minus, till if I continue this, term minus term. So that means any power which is equal to 0 will give you 1. So the k power will go up to t minus t, the maximum number of terms. So here instead of t I can write 4 minus 1, 4 minus 2, 4 minus 3, and there, to make better understanding, it will be 4 minus 4. Well, that means how many terms is there, this will be the maximum number, and that will go up to term minus term, up to that term it will go. If it is 5, there is a 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4, 5 minus 5, up to that it will go. So this will be the one kind of corollary you can say, but this is only possible where the terms are in continuous proportion. Sorry. So now if I do that, now let's say A, B, C are in continuous proportion. So then A is to B is equal to B is to C, or else you can say A is to B is to C are in proportion. That also true because B, the mean B and B are same. That need not to be multiple LCM because both the terms having same LCM. Okay, so if this is the case, so A by B is equal to B by C is equal to K. So A is equal to Bk and B is equal to Ck. So now if I do the ratio of the extremes, this could be a one proof, or you can take it as a corollary. What is the effect of it? A is to B, B is to C is equal to K. So A is to C if I want to calculate, so that is equal to A is equal to your A can be written as Bk, okay, and C can be written as B by K, isn't it? So this will be B cancelled out, K square. That means K is what? Either this square by this square or B square by C square. Any of these two you can write. So that means if they are in continuous proportion, the extremes are in the ratio of the duplicate proportion. So that can be a one of kind that can be proven, or if something comes like that to confuse you, prove that extremes are in the ratio of duplicate proportion of the first two terms. Okay, if there is three terms, you have to prove it is first two terms or the last two terms. This is square means any in two terms A, B, their duplicate ratios will be A square plus B square, and triplicate will be A3 by B3, subduplicate root A, root B, subtriplicate cube root of A, cube root of B. This I have already explained. So these are the things. So this has been proved. Okay. So now earlier case, one more thing I have told. So that is a unique one where three ratios which are not equal ratio, that means A by B, C by D, C by D or E by F, they are not equal ratios, so that cannot be make equal. So in that case, sorry, I have taken this way, I suppose, as I remember, this is small b by and C by capital C. This way I have taken. So example is this, and in this case what I told, if I add the antecedents and if we add the consequents, the ratio whatever we will find will be lie between the lowest fraction to between the highest fraction. This is one kind of thing that I have not proved it, but any random number you can take to prove it. Let it be 2 by 3, let it be 5 by 6, let it be 7 by 8. I am taking any random numbers, and if we want to calculate which one is, for first thing we have to do the LCM of these two, find whatever is highest, whatever is lowest. So do that. 3, 6 and 8, what is the LCM? To know how to do the put the fractions in ascending or descending order, that are the same thing I am doing. So 3, 1, 2, 8, 2, 1, 2, 4, 4 2s are 8, 8 3s are 24. So this means 3 into 24 means 8 into 8, 5 by 6, 6 into 4, multiply 4, 7 by 8, 8 into 3 into 3. So that means 16 by 24, this is 20 by 24, and this is 21 by 24. So out of this, which one is highest? This one is highest and this one is lowest. So from these three, if I want to calculate the sum of the antecedents, This is the sum of the antecedents, and sum of the consequent is this. So what is the value of that? 14 upon 9 and 9 and 8. 9 and 8, 17. So 17. So 17 you have to transfer into 24. A bit difficult, but this is the highest one. So the lowest, if I take the average, this is 2/3, that means almost 0.66. Okay, and the highest one is 7/8, means approximate how much? This is lowest, and highest is 8. 8 into 64, 64, 60, 8, 7. So I'm taking it in 2 decimals. So for that, if I do 17, that will come as 17, 7, 17, 7, 49, 4, 7 on 4, 7, 7, 11. And then after 17 by into 8, if I do 6, 5, 8, 5, 13. Yes. So 0.7 will come, 8 will come. Then after 136, 44, 72. So approximately, if I take the ratio of this, it will come up to the 2 decimal. You can see this is lying between 0.66, 0.82, 0.86, between the highest and the lowest of the fractions that is given. If I do the sum of the antecedents, sum of the consequent. Okay, this was the corollary. Apart from that, whatever will come during the problem solving session. So I will move on to the problem solving session on this ratio and proportion. This chapter is very easy, so I am just moving bit fast. So not much thing has to be explained. Okay, so I think if people can understand it better, so I will move on to the problem solving session starting from 1. Okay, so this kind of chapter I will not stretch for very much, so that it will be a loss of time for the students. So I will give a brief, and then after I will move faster. Okay, so the first problem, A and B together have, this will be a mix of problems. So I am starting with the word problem. That doesn't mean the theoretical, the straightforward theoretical will not come. It will come intermediately. So it is a mix of the problem that I have taken from different sources. So there could be a mixture of things when you will progress. Okay, have rupees 1210. And if you have any subject which is there in your mind to be discussed, please guide me so that I can take that subject. I want always to help students. So wherever you think it's very much essential to discuss a particular subject, that as I have got the request from audience regarding this fluid mechanics I have described. So if some similar subjects, if it is needed to be discussed, kindly give a request in your comment section, and I will definitely come on the I will take up the subjects earliest. Okay, so if 4/15 of A's amount is equal to 2/5 of B's amount, how much amount does B have? Okay, so what is that? A and B together have some rupees. So uh, let it come the next to the first segment of this I will work is this if 4 by 5 of A's amount, this will come first because this will build some relation, because this is a straightforward relation of rupees. So you know the A share plus B share is 12. This is a straightforward relation. Whereas the thing that will guide you better if we consider on this part, if 4/5 of the A's amount, so you will have straightforward, let's say 4/5 of means into of A's share, I am representing A's share, A's amount as A is equal to 2/5 then again of B's amount. So B's amount I am taking as B. There is no ambiguity in that. How much? So now this is one relation where the specific relation between the comparative one is there. So you need not to put it in ratio form, rather because the first equation is A's amount plus B's amount. It is straightforward this much. So you know how to solve equations as because there is two unknown A and B. A's amount given as A, B's amount as B. So A and B together has this much rupees, whereas the relation interbetween is that 4/5 and 2/5. So you can reduce it 5, 3, the 2/3 of A. So this can be reduced further for the calculation sake. 2/3 of A is equal to B. So this is your fine equation after the reduction of the numericals. So then further is A plus B is equal to 12, 10. Now you can replace B's value here with A from the first equation, and you will get this as the equation of A. So this is 5 by 3. So this will become A equal to 3 by 5 of 12, this one. Okay, so now what else? 5, 2, 5, 4, 5, 2 again. So this is 6, 12, 7. Isn't it? 726 is A's value, and B is how much? If B is 2/3 of 726. Now 3 of 224 into 2, so that means is equal to 84, 484. So this will be the A and B's amount. Okay. Problem 2. Two numbers are respectively 20% and 50% more than a third number. Find ratio. Two numbers are respectively with more than a third number, ratio of two numbers. Okay, so you have to find the ratio of two numbers. So although the numbers, third numbers is not taking part, but this is building some relation with the first two. The two numbers, let's say the numbers is A, B and C. The two numbers more than 25% and 15%. So if I say 20% and 50% more than the third number is C. So 20% more means if I say that this is 100, so your A is how much? 20% more means 120, and B is 50% more than the third, that means it is 150. Instead of taking other variable with the percentage, it is an advantage for you to take the base value as 100. So base with which it is being compared, third number. So third number is I am taking as a 100. So respectively the other numbers we can get. So now A is to B, you can get easy ratio, this one. So this is needed, find the ratio between the two numbers. I am taking A as the first, A is the first space, so accordingly you will get the value. So this is 3, 4, 3, 5. So ultimately your answer is 3:5. Now you can also can use it as a corollary. Why? Because if two numbers compared with the other numbers in percentage, so your formula can be, the ratio between AB can be something like that. This could be your formula. Okay. So you can take X percentage, or if it is simply Y percent. If this is taken as X percent, this is taken as Y percent. If it is somewhere it is problem like that, so A is to B is nothing but 1 plus X percent, or this and further can be reduced at X by 100 by 1 plus Y by 100. Anything you can do, but one basic you understanding, if you are able to fetch, you can take it as a direct formula without wasting this much of time. You can put this in formula, but you have to keep the situation in mind. What is what? Two numbers compared to third numbers. In this case, you can put it in formula, direct formula. Somewhere it is useful for competitive examination. So I am just hinting you. Hinting you so that you can save your time in competitive examination. Okay, so there will be so much of tricks that is useful for very short term exams where number of questions are too much. Okay, so next sum is number 3. A sum of money is to be distributed among A, B, C and D in the proportion of 5:2:4:3. If C gets 1,000 rupees, then 1,000 rupees more than D, what is B's share? Okay. Now, in this, there are 4 members, 4 quantities, 4 members who are getting the percentage of in the ratio of sum, which is given in this, with this ratio, sum of money being distributed among 4 with this ratio. Okay. So the thing that the first thing that will come into your mind, this is the quantities in ratios that is the lowest after being converted into the lowest ratio, because the actual quantity is not of this numbers. This must be or maybe of different quantities that is being taken in ratio and being reduced further. So these all are reduced with the same factors that can be a factor to all of the quantities. So I mean to say, if it is 20 for someone, 40 for someone, 80 for someone and 120 for someone, So out of this, which is common factor for this all, we have to divide it and bring it to this. So this may not give you the real quantity picture. So what is that? So what is the common factor by which this has been divided? We can take as a multiplier of this all. Let it be the common multiplication factor. This I am going bit basic way. This may not be the way of teaching in the later sums. So this, as because this is the first one, I am just describing like that. Later on you have to understand automatically what I am going to do, what I am doing exactly. So let the common multiplier of all quantities is x. So if I multiply all this with x, I am getting the exact quantity. So whatever A is getting, it is 5x. What is B is getting 2x. What is C is getting 4x, and what is D is getting is 3x. So I am taking x will be the common factor, multiplication factor, by which if I multiply these numbers, I will get the exact. So now if we put this in ratio, all x will be eliminated, as this is giving no contribution to the ratio itself. It is not changing any value to the ratio. Ratio will be remain same. So this is the only factors that is applicable for both, and I will get the exact amount. So this is the way of solving this kind of ratio problem. So what is the exact amount? A is getting 5x. X could be same anything, but x is same for all. So now this is my first assumption. If C gets 100 rupees more than D, so what is the D's percentage? 3x. And what is C's portion? 4x. So C is getting by D, this is 1000 given. C gets 1000 more than D. So whatever C is having, if we deduct the D's part, I will get 1000. So what is C's part? 4x. What is D's part? 3x. So this will give you 1000. So now from this you can get the value of x. So once you will get the value of x, it is not very tough for you to find the exact value of all. So what is that? 5 into 1000 for A, 2 into 1000 for B, 4 into 1000 for C, and 3 into 1000 for D. So now we will get all the values. So now what else? What is B's share? Now this is automatically resulted. Fine. So this kind of problem, when that ratio is given as a common, you can take a common multiplier of this, which will give you the exact amount of the percentage. Okay. So here I will end this session. In the next session I will move from problem number 4 onwards. Thank you.